Welcome back, guys. So, we are continuing the series of alphabetical glossaries, and today we are starting with B. We have already covered A. So, let's start. So, first one is B ring. What is B ring? As we have discussed earlier, in case of A, that B ring is are the rings A, B, C are the rings of Saturn, and you can see in the in the representation as this. So these are C, B, Kazani division, A and N key gap. This is the Saturn and these are the rings of Saturn. So you guys might be thinking how these rings are formed. So these rings are formed due to crushing of the moons. So basically what happens when a moon is revolving around, when a moon or satellite, an object is revolving around the planet, it is attracted due to its gravitational field. The head, the facing area of the planet, it's more attracted towards the planet, hence it gets an oval shaped, and hence finally get into the field, innermost field, and get crushed out by its atmosphere, by its very strong gravity and atmosphere. So this is how these rings are formed. The rings are there in also Jupiter. There are rings in Jupiter also, but they are not visible. Okay. So yes, and there is a Ricci limit. Ricci limit states that the top is the top is attractive, is discharged first and then destroys the bottom, a moon that stays too close. Okay, due to the tidal force, these rings are formed. Okay. Okay, now we get everything. Now we know everything about rings and how they are formed. We are going to know about the composition of ring in the upcoming lecture, so stay tuned. Okay. Next is background noises. Background noises are simply those noises which are of no relevance. They disturb the activity that we are monitoring. Okay, these background noises can be produced by atmosphere, or there is an issue in the instrument. These are basically unwanted defects or deviations. Okay, next is buried spiral galaxy. Buried spiral galaxies are those in which a black hole is surrounded by matter, and the matter is spinning at a very fast rate and hence making a spiral structure. Okay, what is basalt? Solidified lava and iron magnesium sulfate mixture. So guys, do you know that the most of the crust, yeah, all crust on the earth is made up by the activities due to volcanic eruptions. The matter ejected by the volcanoes from the middle of the earth, and they take it out on the surface, hence creating a crust. Okay, that's why volcanoes are so important. Moreover, the atmosphere as we know it is created by volcanoes itself. What do you think about CO2? Is it harmful, or is it bad, or is it good? So if we take into account that CO2 is very important gas, as it is a greenhouse gas. It is important because it keeps our planet warm, but due to over exploitation our planet is getting heat up due to over emission of CO2 gas. So we must control CO2 gas. It is not necessary that we have to just cut down each and everything which is operating, which is giving CO2 out, but we have to minimize the use of that thing, because CO2 is important but in an adequate amount. Okay, next is baseline, the distance between two observation locations used for the purpose of triangular measurements. The larger the baseline, the bigger the resolution. So for for making a calculation of very big distances in universe, we surely use a triangulation method. This is a very simple and very innovative method. So through this we can calculate distance between very far objects. We are going to make an experiment related to this in the coming lectures. Okay, you're going to learn about this, don't worry. Next is belt, dark low pressure region in the atmosphere of Jovian planets where gas flows downward. Yes. The Jovian planets are those which are made up of metal, like our sun, like our Earth. The Jovian planets are listed as Venus, Mercury, Earth, and Mars. Other planets like Jupiter, Neptune, Uranus, and Saturn, they are gas giants. Okay, so yes, this is the atmosphere. Okay, next is Big Bang. Big Bang. Yes, it's all started with a Big Bang event that cosmologists consider the beginning of the universe, in which all the matter and radiation in the entire universe came into existence. What are the statements in support of Big Bang? Do you know? So first statement or the first law which we consider in the favor of Big Bang is the expansion of universe. Second is the uncertainty principle. The form of uncertainty principle which encourages Big Bang is time and energy time and energy relation. It says that a very high energy can be emitted and in a very small time can be emitted in a very small time, hence making an uncertainty principle follows Big Bang theory. Okay, Big Bang theory is very controversial and has been a matter of debate from decades, so we must consider it with our heart. Okay, next is big chunks. Big chunk. Point of final collapse of a bound universe. Yes. So as we know that the universe we know came into existence due to collapse of different fragments of dust and particles revolving in space. Our planet, our sun, and everything we observe is made up due to collapsing of small fragments. Okay, binary asteroids that have partner in orbit around it. Okay, binary means two, hence partner. Asteroid has a partner with him in the orbiting value. Okay, binary pulse. Yes, binary system in which both components are pulsars. Pulsars are important tools for measuring distances because pulsars are unique as they have same kind of intensity throughout. Hence, by calculating the intensity, we can calculate the distance. Very important. Pulsars are very important. Next are binary star system. Binary as discussed earlier, that is 2. Hence a star system which is very common in our universe is a binary star system in which two stars revolve around each other in around their center of mass. Two stars revolve around their center of mass. Okay. Next is biological evolution, change in population of biological organisms over time. We have evolved due to by making changes to our habitat. By making changes according to our habitat, we have changed. Yes, so this is called biological evolution. Yes, bipolar flow, jets of material expelling down from protostars perpendicular to the surrounding protostellar disk. Bipolar flow is basically means when a hyperbola bursts out, there are two jet streams which are coming out from each side, and the disaster they can make is very significant. Next is black body curve. Yes, do you guys know what is black body? A black body is a body which can emit any range of radiation and can absorb light. Black body doesn't mean that it should be black. Our sun is a black body as it emits variety of radiation. Okay. What is black body curve? The characteristic way in which the intensity of radiation emitted by a hot object depends upon frequency. The frequency at which the emitted intensity is high is indicated by of the temperature of the radiating object after reflecting as the Planck's curve. We are going to discuss the black body curve in detail because it is a very significant topic and involves very much application in our astronomical field. So for reference, it looks like a mountain curve. You can call it a mountain curve. Okay. Next is a black dwarf, the end point of evolution of an isolate low mass star after the white dwarf stage. The star cools to the point where it is dark and clicked into interstellar space. The white dwarf stage of a star is a very crucial stage. In this stage, star has lot of energy and it expels its energy at a very accelerating rate, and after that it started cooling and hence become a black dwarf. Okay, it's just like a dead mass in the space. Okay, next is black holes. A region of space where the pull of gravity is so great that nothing or not even light can escape. A possible outcome of the evolution of very massive stars. The stars which are 10 to 15 times greater than our own sun ends up becoming a black hole in the future, in the layer life cycle. Black hole is a place where God divide zero. Nothing can escape from its event horizon. Yes, and it is one of the fascinating and the most interesting topic that one can study in astronomy. And I think this is a topic which just keys me into astronomy. I just love astronomy because of black holes. They are so mysterious and so powerful. Yes, and black hole give rise to a condition called singularity. At singularity, the density is so high that volume that it can be stored on your hand. It's very heavy, and its density is so high density. Next is blazar, particularly intense active galactic nucleus in which the observed line of sight happens to lie directly along the axis of the high speed jet of particle emitted from the active region. Okay, next is blue giant, large hot bright star at the upper left end of the main sequence of the HR diagram. Its name come from its color and size. We are going to study HR diagrams in detail. HR diagrams are so important as they tells us about various stars, their masses and their life cycle, how they are going to end, and so lot of things. So we are going to study LR diagrams in the topic the stars. Okay, next is blue shift. We have discussed blue shift in our first video. Do you guys remember? If not, please check the description and watch it. Okay, it is the change of apparent frequency as we are approaching it. Frequency increases during the blue shift. Okay, next is blue stagger, star found on the main sequence of HR diagram but which should already have evolved off the main sequence, giving its location on the diagram through to which formed from the merge of lower mass stars. We are going to learn it in the upcoming lessons. Okay, next is blue supergiants. Wow, the very large of the large hot bright stars at the upper left of the main sequence HR diagram. Okay, next is Bohr. Wow, Bohr model, first theory of hydrogen atom to explain the observed spectral lines. This model rests on the three ideas that there is a state of lower energy for electron, that there is maximum energy beyond which the electron is no longer bound to the nucleus, and with that within these two energies the electron can only exist in certain energy levels. Bohr model, yes, very important Bohr model, and one of the prestigious, one of the simplified models of an atom. Next is book globe, dense, compact cloud of interstellar dust and gas on its way of forming to one of the stars. Yes, this is how fragmentation works. Fragmentation will leads to the collapse of gases and hence evolving a bigger mass. So this is just doing the same thing. Okay. So finally, the product of the following will be a cluster of stars, cluster of neutron stars. Next is boson, yes, boson. Particle that exist or mediates force between elementary particles in quantum physics. So boson is responsible. Higgs bosons is responsible for mass on the particle. There are various small particles, very small particles, which are particles, which are they are they are very small particles. They are divisible nucleus. Inside the nucleus they are elementary particles. These are elementary particles and we are going to discuss them very shortly. This is also very good, and there we are going to study about Feynman diagrams and lot of other things. Okay. Next is bound trajectory, path of an object with launch speed lower enough that it could not escape the gravitational pull of the planet. Yes. So do you know what is the escape velocity from Earth? The escape velocity of Earth is 11.2 kilometer per second. If you want to escape from this world, you have to be accelerated through this velocity. Okay. Next is brown dwarf. Brown draft means small. Draft means small. Brown draft reminds of fragments of collapsing gas and dust that did not contain enough mass to initiate core nuclear fusion. Such objects are frozen somewhat along their pre-main sequence concerning phase, continuing cooling into compact dark objects. Because of their small size and low temperature, they are extremely difficult to detect. Because of their color, they are very extremely able to detect. Brown dwarf is one stage of a star evolution. It is not one stage, but it is an alternate stage of a star evolution. When there is not enough mass, it's end up getting cold and becomes a dead burn. Okay. Next is brown oval, feature of Jupiter's atmosphere that appears only at the latitude near 20° north. This structure is long-lived hole in the cloud that allows us to look down the Jupiter's lower atmosphere. Wow, this is like a window which enables us to see in what is going inside the Jupiter planet. Okay, so here we are done with the B letter glossaries. Well, in the next session we are going to continue C, and hope after these sessions we are going to take questions and will go with the specific topics, hence you will be clear with all the fundamentals of astronomy and are good to become a young physicist. Signing off, Dhruv Kumar. Bye.